All right, guys, here we go. It was made to my attention that I didn't have a video for UH Quiz 27 integration review. Yeah, here's my video. So let's get right into it, guys. Let's see, what do we got here? So we have 6x cubed minus 3 over x squared. So the best way to tackle this, guys, if you're dividing by one single term in the bottom, I would just go ahead and just do 6x cubed over x squared minus 3 over x squared. And I guess technically you have that, you have a dx there on the side there. So just simplify it. So 6x cubed over x squared, that's just 6x, guys. And then I'm going to bring this x squared up, so minus 3x to the negative 2, and then the dx. And here we go, antiderivative. So I'm going to add 1 to that exponent and divide by that number. So 6x squared divided by 2. And then minus 3x to the negative 1. Remember, it's a polynomial, so add 1, divide by that number, negative 1 plus c. So there you go, guys. You don't necessarily have to do it like that. I mean, if you already know what's up, like you can just go ahead and just do 3 right here. So that's 3x squared. Negative divided by negative is a positive, so it's going to be plus 3 over x plus c. And there it is. All right, let's go to the next one, guys. So turn these radicals into exponents. So I'm going to go integral 3x to the 1/2 minus, and I'm going to bring this up. When you do that, it's going to be a negative, right? So x to the negative 1/2 plus 7e to the x, so the dx there. And here we go. I'm going to do antiderivative. So add 1 to the exponent, divide by that number. So 3x to the 3/2, because 1.5 plus 1 is 1.5. Divide by 3/2, which is the same thing as multiplying by 2/3, minus x to the 1/2 divided by 1/2, which is the same thing as multiplying by 2, plus 7e to the x plus c. All right, let's simplify this. These 3's cancel out, so you have 2x to the 3/2 minus 2 square root of x plus 7e to the x plus c. And let's look for that. And there it is, guys. So far, so good. Let's go to the next one. So they're telling you this is my derivative, this is my initial condition, and so you're just going to have to do an antiderivative, guys. So do antiderivative, so I'm going to write f of x equals, because I'm doing antiderivative of 9 cosine x, that's going to be a 9 sine x, and then plus c. And everything checks out. If you take the derivative of this, you'll get 9 cosine x, as you can see. Use your initial condition, guys. 2 equals 9 sine of 0 plus c. 9 sine of 0 is just 0, so c equals 2. Now I know that c equals 2, just go ahead and plug it in right there. So f of x is equal to 9 sine x plus 2. So 9 sine x plus 2, so there it is. This one right here, guys, is just a straightforward one. Hopefully you remember from your first semester, d dx of arctan of u equals 1 over 1 plus u squared du dx. And you can have 1 over 1 plus u squared or 1 over u squared plus 1. It doesn't matter. It's the same deal. So that's going to just be arctan. Arctan of x plus c. And there it is. So we got the first 4 questions out of the way. Let's keep going. This is a perfect example to do u substitution. Chav, how do you know? Because you have an x squared plus 5 in there. When you take the derivative of that, you have a linear expression. And I have a linear expression in the numerator, which is what I want, guys. So u equals x squared plus 5. So du is going to be equal to 2x dx. I'm going to rewrite this. Integral, I'm going to put that 5 on the outside. So 5. And I'm going to write x over parentheses x squared plus 5, close it, squared dx. And I'm going to change my color here because I need a 2x dx. So I'm going to put a 2 there. If I put a 2 there, I put a 2 in the bottom to balance it out. And I think we're good now. So 5/2 integral 2x dx is your du, but put it on the side there. 1 over u squared du. So remember, this is just u to the negative 2. So 5/2, add 1, divide by that number. So u to the negative 1 divided by negative 1 plus c. I'm going to put that negative in the front now, negative 5/2. And I'm going to bring the u down. So times 1 over what was u? U was x squared plus 5. Since this is an indefinite integral. So x squared plus 5 plus c. So my final answer, distribute that 2 there. So I'm going to have negative 5 over 2x squared plus 10 plus c. So that negative could be there in the top, or it could be in the front there, or they could distribute it to the denominator. But there it is, and we look for that, and there is my negative in the front. And there we go, guys. Okay, let's keep going. So this is the fourth root. It just didn't come out really awesome. So let's see, 7x squared, fourth root of x cubed plus 3 dx. So I'm going to write u equals x cubed plus 3. So, and by the way, why am I doing u substitution? Because I noticed that I have a 7x squared, which is 1 degree less than the x cubed, so it's going to be perfect for this. So du is going to be 3x squared dx. I'm going to bring that 7 outside, 7 integral. And so I'm just rewriting this, guys. Fourth root of x cubed plus 3. So make sure that's the fourth root there, guys, dx. So here we go. I'm going to plug in a 3 here. So there's my 3x squared dx. So I need to put a 3 in the bottom. And I think we're good now. So 7/3 integral. That 3x squared dx is du, but put it at the end. And then x cubed plus 3 is u. So I'm going to write u to the 1/4, law of exponents, du. All right, we're good. So here we go. 7/3, leave a little bit of space. U, I'm going to add 1 to that 1/4, so 5/4. Divide by 5/4, which is the same thing as multiply by 4/5, plus c. All right, since this is an indefinite integral, we're going to go back to our u here. We're going to go back to our x here. We don't do that in real life. We don't go back to our x. But in this case, it's indefinite. It was never about u, so we have to go back to our x here. So let's see. 7 times 4, 28. 5 times 3, 15. And then parentheses, the u was x cubed plus 3. So x cubed plus 3, close it to the 5/4 plus c. And there it is, guys. So let's look for that. And here it is. Yay. All right, let's go to the next one. Again, so I see an x squared plus 2x minus 2. And when I do my du, I can see that I'm going to have a linear term. Chav, I don't understand what you're saying. So look, let's just do it. U equals x squared plus 2x minus 2. And notice when I do my du, 2x plus 2 dx. If you want to put parentheses like that, go for it, guys. So I can get this to be a 2x plus 2 if I factor out a 4. So here's my integral. I'm just rewriting it. I'm not balancing it out because I don't need to. 4 parentheses, 2x plus 2, close it, over square root of x squared plus 2x minus 2 with a dx on the side. And there it is, guys. So this is my u, and all this right here, 2x dx, 2x plus 2 dx is your du. So I'm going to write integral. I'm going to put that 4 on the outside, and I'm going to have 1 over square root of u du. So let's rewrite it. Let's keep going. Integral u to the negative half du. All right, here we go. Excuse me. 4 times, add 1, so u to the half, divided by half, so times 2, plus c. 4 times 2 is 8, so 8 square root, and then the u was x squared plus 2x, so x squared plus 2x minus 2, and then plus c on the outside, and there is our answer, guys. All right, let's keep going. This is going to be another u substitution because I have a linear on the outside and a squared minus x squared on the inside. So u equals a squared minus x squared. So du, the a is a constant, is a negative 2x dx. So let's see. I'm going to put the 9 on the outside. Integral. I'm going to have new limits. Okay, let's rewrite it. So right now I have x square root of a squared minus x squared dx. And I guess I'm still with x here. So, but we're going to go in terms of u now. We're not going to go back to our x this time. So I need a negative 2. If I put a negative 2 there, I got to put a negative 2 in the bottom there. So negative 2x dx is du, and this guy right here is u. So let's rewrite it. So negative 9/2 integral square root of u. So I'm going to write u to the 1/2 du. Put the du in the end, guys. All right, when x is 0, plug in a 0 in for x, you get a squared. When x is a, plug in an a for x right here. A squared minus a squared, that's a 0. And there it is. We're not going back to our x, guys, because we have definite integrals. This integral here is equivalent to this one, so they're the same. So I'm going to go ahead and reverse the polarities. And so that means that negative is going to turn to a positive. So 9/2 integral 0 to a squared of u to the 1/2 du. All right, here we go. So 9/2 times, I'm going to add 1 to that half, so u to the 3/2, divided by 3/2, which is the same thing as multiplying by 2/3, evaluated from 0 to a squared. The 2's cancel out. 9 divided by 3 is 3, and I'm going to leave that factored out, 3, parenthesis, and I'm going to go a squared to the 3/2 minus 0 to the 3/2. And I guess you don't need to do the 0 there because we know that 0 to anything is 0, except for the 0 to 0, but that's in indeterminate form, but that's another topic for another day. So a squared to the 3/2, the squares cancel out there. When you have an exponent raised to an exponent, you multiply them. So that's going to be a cubed, and then so you just have 3a cubed. Let's keep going. You don't necessarily need to do u substitution on this one, but you could if you want. U equals 2x plus 3, du equals 2 dx. And I know some of you guys see it, so you don't have to do u substitution. So let's see, I don't have a 2, so I'll put a 2, I guess a 2 there and a 1/2 on the outside. So 1/2 integral cosine u du. So 1/2 antiderivative of cosine is sine, so sine u plus c, and then just plug back in what u is. 1/2 sine of 2x plus 3 plus c. You don't have to do that, guys. You could have just done your linear properties. Chop, what are you talking about, linear properties? Or linear argument, right? So you could have used this integral cosine ku du. That's going to be 1 over k sine of ku plus c. You could have just done that, see? And I know you're like, well, what about that plus 3? That doesn't look like that. It's k. The 3 is a constant, so if you would have done chain rule with this, you'll get back to your cosine 2x plus 3. See, 1/2 derivative of sine is cosine, 2x plus 3, the derivative of constant is 0, times 2, and then the 1/2 and 2 go away, and you get the cosine 2x plus 3. Hopefully that makes sense. If I didn't go too fast there. Same thing with this one, guys. You don't have to do u sub. You could just do it. You can already see it's 1 over 5 on the outside. But if you don't see it, then just do u sub. It's not a big deal, guys. 5x plus 4, so du is going to be 5 dx. I don't have a 5 dx, put a 5, put a 1/5. So there it is, 1/5 integral secant u tan u du. And then antiderivative of secant u tan u is just secant u. So 1/5 secant u plus c, and then plug back what u is. U is that, so 1/5 secant of 5x plus 4 plus c. Let's see, what do we got next? All right, so on this one, I see a cosine and a sine. So it looks to me like the better answer, or this is going to be a u sub. The better u is going to be the cosine x, guys, because then du is equal to negative sine x dx. Sine x dx, there it is. The derivative of cosine is negative sine. So I need a negative, so I'm going to put a negative right there. And remember, it's a product there, so now I can do u substitution, integral u to the 7th du. If I put a negative on the inside, I have to put a negative on the outside, so negative on the outside. So negative u to the 8th over 8 plus c. Plug back what u is. So negative cosine to the 8th power of x over 8 plus c. You could also just say negative 1/8, which they do here. And there it is. All right, what do we got left? All right, I see an exponent that's 8x squared, and I see when I take a derivative, I get a linear expression. So I'm going to make u equal to 8x squared. So my du is going to be 16x dx. So I don't have a 16x dx, so I just force it. I put a 16 on the inside. I put a 1/16 on the outside. So here we go. 1/16 integral. 16x dx is du, but put that at the end. E to the u du. So I get 1/16 e to the u plus c, because antiderivative of e to the u is itself. And then just plug back what u is. 1/16 e to the 8x squared plus c. All right, what do we got next here? Okay, so this looks like, I guess that you can let your answers give you a hint. Arc sine, so all I see is inverse trig. So remember, the derivative of arcsine has a square root on it, so it can't be that one. So it's obviously an arctan. So let's make this guy look like my u here. Child, what are you talking about? So ddx of arctan of u equals 1 over 1 plus u squared du dx. That's what I want it to look like. So let's rewrite it. E to the x over 1 plus parenthesis. The only way to get a 4 is if you square 2. 2 squared is 4. So you're going to have 2 e to the x, close it squared, and then put a dx. And there it is. So 2 e to the x, when I square it, I get 4 e to the 2x. So my u is 2e to the x. So my du is 2e to the x dx. I'm going to plug in a 2 on the inside, put a 1/2 on the outside, and now I have 1/2 integral, and then e to the x dx with the 2 in there. See, I plug it in a 2. So we'll put that half there. That 2 e to the x dx, that's your du. And then I'm going to have 1 over 1 plus u squared du. And now it's just 1/2. So that equals 1/2 arctan of u. That's my arctan. It just comes out pretty bad there. So -1 plus c. And u was 2 e to the x. So 1/2 arctan of 2 e to the x plus c. All right. Yay. I'm happy, guys. I am happy to be doing this at 1:15 a.m. or I guess 1:16 a.m. Give it a thumbs up if it helped you guys out. If hopefully all that was nice. And all right, I'm gonna go ahead and hit the hay and see if I can get 3-4 hours of sleep. All right. Talk to you guys later. Bye.